Okay. So now, so far we are discussing about in the BMM layer modeling. Okay, how do we model? In this category, uh, we have seen one activity, that is like you can have one logical table pointing to one LTS, that is nothing but a logical table source, and that is pointing to multiple physical tables. So we are just seeing a type of modeling where we can have multiple physical tables pointing to LTS. So whenever, one use case when you have to go by this option, whenever you are looking for a calculations from multiple tables in a physical, okay, physical calculation. So this is the only option, there is no other option. This is one use case. The second use case would be whenever you want to convert a normalized tables to logical denormalization. Okay, so mostly it is not that much important, but sometimes. Okay, I'll give you one more example of that one. Say for example, now in our model we have a customer table. So this is also one of the discussion topic in OBIEE sometimes. So have a customer table. If you have fact table and then directly joining with customer table, and we know what is the difference from the star and Snowflake star. What is star schema? Maybe in our technical terminology. Yeah, you'll have a, yeah, surrounded by dimensions. Dimensions are fully denormalized. Snowflake, we may have dimensions to be snowflaked or normalized to some extent. So in our case, so far we have used only one customer table. Okay, but here I have one more table. Okay, address. So out of these two tables, right now so far we used only customer table, and this customer table has some information. So we have customer number, customer name, type, all that information we already seen, we have it. Okay, and here we have one column which is called address ID. Okay, so address key. So this address key means, you see, marital status and lot of information is there, but we don't have the detailed address in this table. So we have only address key, address number. Okay, so for one customer, this is the address number. But if I go and see this table, for that address number, address key, what is the detailed address? Okay, what is the postal address, city, state, country, and latitude, longitude, region, country name, and all that information we have here, including the area. Okay, so now if I go to this table and then if I look for address key equal to, so now we'll come to know for that particular customer, okay, the detailed address is this. So this is one example here. So now we have not used this table so far in the repository. So for the first time I am trying to bring this table into I am bringing additional table to OBIEE here. So these are the table present already, and now I am trying to get for this table. So these tables, okay, we have some degenerate dimensions. Okay, we have seen couple of example degenerate dimensions where have written some SQLs and all. So this example was something. This also you can use, but this is actually a different purpose. Okay, we used in a different purpose. But this time we have customer data here and we have address information here. This has the customers and this has the address information. So now I want to relate. Physically means since some information in the customer table and some information in the address table, the two tables, it is one of the example of this Snowflake model. We have a fact table here. Revenue fact table is here. Customer table and now. So if I am leaving, I am ending with the customer, this is a star schema. And now we have some data in address also. This is a Snowflake example. So here also I need to model it. I need to relate them. Okay, so I am going to link. We know the join condition. Just now I have seen. What could be the join condition here? In address table we have address key. In customer table also we have address key. That would be the join condition. So that is pretty simple directly. So now here I am going to create a join from the address to customer. Okay, so now here sometimes it is like one address maybe or can have by multiple customers, or one customer may have multiple address. It all depends on how you are designing the table. So right now I am not worrying too much about that. Okay, so now here I have just taken a relation. So from the address table, address key is there, and from the customer table also address key. So one address, there can be, okay, two customers having same address. Okay, so that is also possible, or sometimes it is possible that, okay, for one customer there will be two addresses, for one address there will be two customers. It is all depends on how you arrange your data. So that's why I am not worried about here. Okay, so just leave it. Okay, so but I have joined it. So since it is a physical join, I am not too much worried about I am worried about only condition, because in a physical layer, what is important? In physical only the join condition is important, remaining I am not worried. Okay, so I am done. But when it comes to this table here, when I drag this table from here to here, address table, depending on if it is at many side, it will show like a fact table. It is one side, it will show like a dimension table. So that the conditions are applied here. But here I am not too much worried about to behave this table like a dimension or a fact. So this is a expansion to the customer. just this information is expansion to the customer. So I do not want to keep this as a separate table here. I just want to combine this because it is a really it is address is whose address, it is a customer. But the only thing is, since you have split into two tables, it is Snowflake star. But actually speaking, this information is same. That's why rather than you adding this table separately outside, whenever you want to add this table to inside of one dimension table. So option one is we already know I can drag this table from here to here. That is every time we are doing. But this time what I am choosing, rather than choosing this table to come as a separate table and act like a separate table, I am trying to combine this into customer table itself. This is the customer details. So these are the columns because this table is currently nothing but this table. Okay. So we have all these columns. So what I am doing, I am just double clicking this. Okay, just see, notice what are the columns we have. These are the columns. And rather than bringing this address table to the outside as a separate table, I am planning to add this table within this table. This is the previous modeling style, adding multiple physical tables to a single LTS. Okay, so now address is directly joined with customer table. I can happily select and then join. Say select address. I am selecting from where it is coming. It is coming from the physical. You can choose this one or you can choose this one. Both are same actually. And say OK. So now if you see, now you will see only one logical table, but internally it is pointing to two. So that's why OBIEE BMM layer can convert Snowflake star to logical star. So now when you have one table, you'll see in a BMM layer only one table, but actually they are two tables. So that's why when you see what is BMM layer means, it will convert Snowflake star to logical star. So that is the actual best practice of the OBIEE. Okay, so that's why I will have, if I go to BMM model, you don't need to worry about whether it's a fact or a dimension. It is one table for us. But inside you have the two other tables. So this is one of the technique modeling. So now since you already have added address table in the within the LTS, now I can go and happily select. So now from this table, so now when you add a table here, you see there are no columns added here. Only table has been added. Now I can go and happily add what are the other information you want. I want area. Just drag and release here. Area will be added here. Okay, and then I want city, country name, and postal code, region, state I want. All these columns we add here. So you will have one dimension table. What is this? It is a logical dimension table, but containing the column of two dimension tables, two tables in a physical. That's why it is a logical conversion of the Snowflake to star. Okay, so now okay, if I want to create a hierarchy, okay, say for example, so far I have not created, I am going to create a new hierarchy, logical dimension. So first I'll start from region. So I have a column region, so I can place this into region. Hierarchy I am creating. After region we have country. After country we have state. After state I say area. Okay, and under city, okay, so now I can start using some other columns, right, where marital status. Under marital status I'll select. So this is one example, two in one example. I am creating a hierarchy based on two-dimensional columns. So I am able to, means we will be in a position to create hierarchies based on two tables also. So now this hierarchy doesn't contain columns from a single table. So this hierarchy right now contains columns from two tables. So marital status, customer details are coming from the customer, remaining all coming from the address table. So we have mixed it. So this is also quite possible. Most of the times you'll have this situation. Okay, so now I'll add area to area, country over state. And last customer ID, I'm going to keep the customer ID. And now I just bring this customer table again here because I had some extra columns added here. So this is one of the use case of adding multiple physical table to a single LTS. You can create, so one of the benefit is you can create physical calculations from multiple physical tables. You can combine two tables into single table, and then you can create a hierarchy on that one. Okay, so a number of things you can find out over here. Okay, if I can select in the every region what is the total number of some units. Okay, so this is the region wise, what is the total. Then I can go country wise. Okay, in this region we have these countries, and each country we have this state. Okay, for here we don't have these states, but here we have these states. Okay, and further it will continue like this area. Okay, so this is one of the other benefit of the having multiple table in it. So that's the reason large BMM layer, if you say, converts physical Snowflake star to here, anything to anything. Okay, and we'll take one more example, then we'll get into this yellow situation, multiple LTS. Okay, now we are talking about other situation. Okay, this is one use case where so one situation is create physical calculations based on two different and the situation B, convert this so the second situation which I am talking here is okay, design create measures on fact table, sorry, dimension table. This is another situation. Okay, so try to use these words because you may not be in a position to explain. Okay, if you are a new to data and OBIEE, so you can use these words. Okay, the jargons when you are explained. Okay. So now we have seen A and B situations here, and now the second situation is, okay, this is one of the easiest situation. I'll tell you the problem statement. So just remember by the use cases, because I think better I'll go by use cases always. So now I have a situation where boss is asking something. Okay. Which one you want me to explain? No, which one? Which one? Okay, physical. Now we have seen, right, case statement example. Okay, if you want, you can just make a note of case statement here. Just remember case statement, that should be sufficient. So now this will be a bit small one, but also interesting one. So now we have all these tables. I have customers, we have everything. So now I have a fact table, and we have created measures and a lot of things is there. What is the total quantity? What is the, all these measures we have created, created. So now I want to create one calculation. This is also one calculation, which will give me how many number of customers we have currently in our organization. So now maybe you know little bit, you have little bit of knowledge on this table side. So from which table I need to get this information? So my question is, how many number of customers we have in our organization? I want to find out. So on which table I need to calculate this measure? What is that number of customers means count of customers. So in which table I need to calculate? Customers. So generally in BMM layer, so where do we do these calculations? In BMM layer. So in OBIEE, we cannot create summarized calculations. Calculation means here what type of calculation? Not let's A plus B or customer first name concatenating with the, we are not applying the derivations. So this is something you have to apply summarized calculation. Summarization you have to do, means count, min, max kind of thing. These summarized derivations can be written only in fact table. So in the BMM layer, okay, if it is a fact table, then only I can apply all those things. You can also apply, but OBIEE will not accept. In the runtime it will fail. Means we cannot create a summarized or summary, we cannot apply summary functions on a non-fact table column. Because the rule is, what is dimension modeling? Fact table only contains measures. Dimensions will not contain measures. But here we want that information, because it doesn't mean that, okay, it is really measurable information, but I am planning to get it from a customer dimension table. So that's why in BMM layer we can also convert whatever table is there. It is my wish how I am planning to use. That is the reason it is a logical, it is a dummy. Okay, so we already have a customer table here. It is acting like a dimension table, but I cannot create count or anything on this particular table. So that's why I'm taking this customer table in the physical layer again and dragging to BMM layer again. So when you drag, you can see the table has been added here. Added or not? Okay, not dragged it seems. Okay, so now I dragged this table to BMM layer here. So now it is showing as a fact table. So this hash represents fact table, we know. So why it may show as a fact table right now? You already have, and this you have added again. Okay, that's why it is not joined to any table. So if any table is not joined to the any other table, means which is isolated, will be considered as a fact table. But still it is not right. Leaving this as it is not right. That's why, what is this table? This table is actually customer. We already have it, but this I am planning to use for a different context. What context purpose? To create some calculations on this. So add the table here. So this table is nothing but customer table, and there is no real. Already you have a join everything. So that's why what you do? You create a logical join here. I am selecting new join here. Okay, and then I am linking from the this table to this table. So now this time I am ensuring that customer details is this one, underscore D is this one. So this is at n side. Since the logical joins will never give the condition, so it is just nothing actually. Okay, so that's why if you see, this is the table, customer details is one side, customer D as n side, and there is no join condition at all, because logical joins are only just to give a relationship, that's all. We are not going to give any condition. Say okay. Okay, now that, okay, this table I am planning to use as a fact table, so I can rename, you can keep it as it is, but since I know that this is a different purpose, I am using fact customers. It is not a real customer table in a physical layer, but I brought it, and this I am using, behaving, making it to behave like a fact table. So that's the hash symbol. So whenever this is represented as hash, so I can go and say count of customer or anything. Okay. So I don't need all these columns. I just need only, if you want average of income level or anything related to summarize the calculation, if you want on these columns, you can happily do. But since I need only one, I'm just showing a simple example. So I can take this customer key, duplicate, and this column I am making as number of customers, and for this column I am giving as count or distinct count, any say. So even if you don't want other columns, you can delete it. I need only this column, that's all. If you can delete all of them also, no problem. And this column I can go and place into other side, or I can place. So this is also one metric. So I can place this into this one or outside, because we know that I can place this column in BMM physical presentation layer any place. But since I am grouping all the measures into one place, I left this column into this. So like this, if you want how many number of products you have in your shop, okay, and how many number of branches you have in your office, in your organization, and anything total counts, or any time if you want to perform any aggregations, or if you want to apply any summarized calculations on a dimension table columns, you bring it to BMM layer and then make this table to behave like a fact table, but is not a real fact table. That's the reason it is a BMM logical layer. Okay, so now I'll go and So we have number of customers, okay, 1,000 customers we have. If I go and see in the count in a customer, and if you see the actual query, so this you have to join with same. If you join it with other table, then that will take into different way. So we'll see why we have to join with same table. Now you will understand. If you join with other table, but again you have to make this to act like a fact only. Okay, so there is no purpose of this one. There is no real need for me to join this table to other table. Only I want to make this table to happen like a fact table. So this will tell you two, it will address two interview questions now. Okay, and now let me show the actual SQL. See, select count of customer key from customers table. Now just to see, apart from this, I am selecting one more column here. What is that? Fine, this is the total number of customers. I want to see how many numbers. See, this time I am selecting a column from a real dimension table. Okay, now I want to see how many number of customers we have in each and every marital status category. Actually speaking, marital status is also from customer table, this is also customer table, but this column I put into customer fact side, and this is really coming from that, but both are actually same. If you go and now you are happily see how many married people are there, how many widow people are there, how many single are there, everything will get. And if you go and see your SQLs here, select customer key marital status one, so it knows that both are same tables. Okay, so still it is not behaving or treating them as a two tables. It went and realized that both are same. That's why actually in presentation layer and the BMN layer, these two tables are different, but it realized that it is just only same table. I can get this information by putting a single query. So you got it. So marital status and count of customers. So you select anything. So this is one of the use case. Okay. Create measures on dimensions. Creating measures means like summarizing. If you are okay, so this is one standard question. So how you have to get this information? How do you do? Okay, so you have to make this as a logical, act like a logical fact table and then get it. And then another use case is that create a repository with a single table. So create the, I will give you one table, I will give you a single. So since we are in online, okay, I cannot show, but I'll just quickly show you. This is another example and then stop it. I'm building a new repository. This is a fresh new repository. So I given only one repository, one table. I have only one table in my entire project. Example, have here, have here, everything we have here. So can we create a repository with one table? So right now we have only one table. So since there is only one table, I cannot do anything. I can only add one table. There also I can add only one table because I don't have. But still I want to generate reports from that. I gave one big table, 200 columns are there, and I want to generate reports from that. So OBIEE BMM layer always works if it is a star schema only, star at least Snowflake. That is the fundamental of the reporting. So it is not a star schema. Why? We don't have dimensions. Because I cannot keep anything because I have only one table. Okay, the simple solution is, we know BMM layer is a dummy. Is all your business wise. Physical, that is the now you will know the meaning of physical BM, logical. Physical means which is really present. Logical means all dummy only. All your visualization. Okay. So I can, people will tell a lot of different answers. One of the simple model for this particular problem is, you take this employee table again, just leave it. Table is one, but how many times we are adding here? 2. Now you go to BMM layer. You choose both, since both are same. Okay, you take anything to anything. One will be dimension, one will be fact. Both are same. Table is one only. I've added 2 times. That will be acting like a dimension, acting like a fact. This should be your answer. But most of the people will tell that I will create a alias to this one, lot of stories. That is not really required. How to create a repository with a single table? You just add files, that's all. Link it. It is all logical linking only. So now things will be done. Is consistent. Okay, so this will help you to understand what is create a repository with a single table. This is also the second situation, scenario. These are all questions basically. Okay, so now we have a third scenario. They are all bit interesting ones. Okay, but you will not realize, but they will be part of your interview questions. So that scenario is multiple, that we'll be discussing from tomorrow. Designing multiple LTS to a single logical table. Okay, so this will get into the situation in 2 scenarios. One is, this is also very popularly known as designing multiple fact tables or working with multiple fact tables, or this is also known as header detail situation. And in a very popular data warehousing terminology, this is also known as Chasm trap. Okay, all are same. Okay, some people will call. Okay, designing multiple fact tables means how can you create reports from multiple fact tables. This is also known as header detail situation. Okay, we have to learn what is that, why, what is the problem with that, and what is the solution. And also in a data warehousing terminology, this word generally people will use in VO. Okay, Chasm trap and all that. Okay, we'll see what is that. So this is one situation, and then second situation is designing aggregate tables. Okay, so in the both A and B situations, we'll be using multiple LTSs into a single logical table. Okay, so I'll give a brief introduction about this problem, then we'll, okay, I'll give you one problem statement, the solution we'll see tomorrow. So now I think I should have these tables present. Let me check here. This is not the good one. I think this is the best one. Okay, so just to see this, what is this? Not this one. So I just one record I have here. What is two column office and then number of employees? So is it a fact or a dimension? By looking at this table, whatever basic knowledge you apply, fact, because we have a measure. Number of employees is a measure, so that's why you call it as a fact. So now, so what is this? Whether it's a dimension or a fact? Dimension, dimension or a fact? Do you have any dimension column here? Very simple. Anything which have a measure, it is quantity, price. They are the measures. So it is fact table. So both are fact table. So now in this table I have in every office how many number of employees we have here. That is already there. Okay. So this information I can anyway quickly get it in a office. One means office number ID is 1 and how many employees are there? 200. That is pretty straightforward. Now this table we have, what this contains, office means let's say we have a Big Bazaar branch, that is office ID is 1. In this Big Bazaar branch we have so many orders. This guy went and purchased something, this guy went and, those are all orders. So first order placed on 29th January in this branch, that is office, and they purchased one LCD, quantity is one and then price is this. Quantity is this much, this much. So now, how many total quantities are sold out? Forget about the products. What is the total quantity? 538 plus 9. So now I want to see one report, information in together. In every office, office number is 1. Office number 1. In that, how many employees are there? How many quantities we sold out? So quantity is where in this which table? This table. And number of employees is where? HR table. So now I want to see them together. So what to do? If I have some column here, if I have some column here, what should I do? I have to join. So what is the common column from these two tables? Office key. So now select office underscore key. So this I'll select from yeah, I'll say column. Okay, let's do something. So this is A table, okay, office, I'll say, or else I can say office table. OFF is the office table. Okay, so this I am selecting from office dot office key, sum of number of employees, comma, this table I will give it as a name as orders. And from orders tables, what column I want? Sum of QDY. Okay, next what is that they need? Where office dot, anyway we have here. Now we have given office, right? Alias we have given. For that we have given a name alias office. So this table is nothing but office. This table is nothing but orders. Just to make you easily understand, I gave alias names. Then also we need group by. So we know very clearly how many number of employees we have? 200. What is the total order? 9. So now I am just putting all this information together. So how many, it is, your query is successful, and what is the information we have now? 9. Sum of the quantity is 9, right? But how many employees it says? 600. There is nothing, I mean, there is no failure. You get the information, but it is showing 600. But how much it should be? 200 only, because we have a real 200. So now any idea what is the problem? This is called what we discussed here, the popular topic in a reporting site. This is called header detail situation, and very popularly it is called Chasm trap. Okay, your query got into Chasm trap. Okay, whenever you are trying to join two fact tables, so these are the two fact tables right now. So we have two fact tables. We are joining two fact tables. Technically, I don't have any problem. We have a common column. I joined and then I can submit. You got it. But your data is not coming correct. One is coming correct. And the reason is these are two fact tables. Everybody agrees. When you join two fact tables, when they are in one to many relationship, what we have discussed, what is relationship or cardinality? If I take one record, okay, if I have a office here, one, how many times we have here? Because we are storing in every office how many employees are there. But if I go to the second table here, how many times you will get that office? One, if you have 1 million, 1 crore, I cannot stop it. Because as you keep placing order in this Big Bazaar branch, you have keep having more number of records for that. One too many. So what is happening when you are joining? Join SQL fundamentally is have this 200. And sorry. And this is the data in a second table. And this is the common column. Okay. So when you join two tables, every record will go and join all matched records. That is a join principle. So this, since it is a join kind, how many matches we have on the left side? 3 matches we have. So this record will go and try to join with this record because it is a match. This will also join with this record. This will also join with this record. So I cannot write a query like this. So left side having 3 records and right side having 3 records, left side having 1 record is not possible in SQL. Okay, means it will join. It is joining with all 3 records. So whenever you join, this is what going to happen. Okay, and when you join, and then when you now after joining and once you get output, you are summing up because we return sum of number of employees and sum of quantity. So now how much you will get? So that is the reason we cannot join two fact tables directly if they are in different granularity, different cardinality, means one to many. It is a basic principle of SQL. Okay. So, but still we can make it query to work it properly. So that is the solution. So we have to learn how we provide a solution in OBIEE for this. So now I am writing a solution in Oracle, and that we'll see tomorrow how we will give a solution in OBIEE. So this can be done in, let me write in a very different way, that will be easy. So now I am not directly joining with this fact table. So office is there as it is, but in the place of the orders is the second fact table. Okay, so I'll explain you how this works tomorrow. Order office. Just check for the spelling mistakes. What happened? QTY is there. What is that error? Office is there. Orders is the same thing. Select star from office. No, no, not. Okay, okay. Yeah, that is right. This is the one. This is the right one actually. Okay, we don't have the office table because I by mistake and I supposed to delete. I deleted this. Okay, so select office. We don't have office table because office is alias table. So when you copy paste, it happens like this. So this is also not there. So this is also not there. Okay. So now things should work now. So this is your HTTP table because we don't have office table. Okay, so I'm selecting data directly from the main fact table and then calculating orders data separately right side. Okay, and then joining it and then. So how this works? Okay, I'll explain you tomorrow. Okay, so the theoretical fundamental is I'm not directly joining. I'm calculating individually and then writing it. Okay, so sorry for this. Office is not at all there. Okay, so how this query will work and how we will give the solution in OBIEE we'll see tomorrow. And the solution for this is adding multiple LTSs to a single logical table. Okay, that will work out tomorrow.